Review time, the Bell+Howell UltraBulb. As seen on TV, there was a lot of infomercials in 2014, late at night I recall, on this bulb. Now, Bell+Howell ceased to exist long ago. Their corporate history is quite interesting, but I think they're mostly just licensing their name out to people who want to put it onto their products. It's an 800 watt equivalency light bulb, so it's about a 60 watt light bulb. The first thing, of course, is Bell+Howell doesn't really exist as a company, but who made it? Let me pop up the UL listing. This little number here is just fantastic for finding out more about it. It's the Ningbo Better Lighting. They spelled better wrong. Let's see. They are just south of Shanghai, south of the Hangzhou Bay. A really interesting part of the world for high tech. People are now migrating out of Shanghai because it's too expensive and into the further lands. So that makes sense. It's a pretty low value add product. Let's tear it apart and see what's inside it. Okay, probably the most common construction for an LED light bulb. It's like a plastic dome. It has an emitter ray on a metallized substrate for heat reasons, all pointing in one direction. That's a really common structure for an LED light bulb. Okay, emitter ray has obviously been popped off here. There's lots of thermal grease that allows the heat to transmit from the edge of the emitter ray into this heat sink and then be rejected to the environment. That's good. What's a bit unusual is there's no potting compound often put in bulbs to spread the heat out so parts don't get super hot in localized areas. Not present in this bulb. You can see it's just a circuit board sitting there. Okay, reverse engineering time. This is a fun bit. Let's see, this is a fuse, of course, and that's an inductor, it's a capacitor. This is the filter for conducted emissions, that's for safety. The bulb has UL listings, so that's good. Yellow thing, is it a transformer or is it an inductor? It is marked as an L, which is, of course, for an inductor. And if you flip on the back, you can see only two terminals, which tells me that we're looking at a non-isolated design. Let's see, full wave bridge rectifier, some nice cutouts here for creepage distances, that's nice to see. And here's the controller IC. And much to my surprise, it's actually marked in a way that you can find a data sheet. Let me just pop up. It's a deep Chinese company, Kalen Tech. I'm not very familiar with it, but undoubtedly excellent choice for a Chinese vendor to procure material directly out of a local source for cost reasons. Let's just pop in some other pictures here. You can sort of see how the board's built. It's got components, of course, only on one side. Sorry, it only has thermal components on one side and surface mount on the other. You can see that this company doesn't own a lead cutting machine. If I just zoom in a picture here, that's some macro photography. You can see the cut marks of a side cutter, and they're all at different angles, meaning that rather than having all the leads trimmed off by machine, it's done by somebody at the end of the line. You can see the process control is ho-hum. I'll insert another picture here. Here's some solder problems. You can tell probably the board is wave solder when we look at on the side here. And if you look at the solder buildup on one side, it's too much on one side, not enough on the other for this part here. Let me insert another macro photography. You can see that they have an uneven solder distribution. So undoubtedly, I mean, everything about this assembly tells me it's exactly what I would expect. It's probably a very small company in the far outskirts of Shanghai. Probably doesn't have a great number of people, and they're producing some cost-effective bulbs. Now, the reason all this is kind of interesting, it's more of a business thing. The LED market is consolidating, and companies like Philips, for example, are now breaking themselves apart. They're kicking off their lighting group into another organization. And some of the Japanese manufacturers of light bulbs are giving up and pulling back into their domestic market. And these small little firms in China right now are thriving. So in terms of flicker, there essentially isn't any. It's a flicker-free bulb from what I can see. So the polar graph basically shows a light bulb which primarily fires down, but has reasonably decent side lobe, so it's not a bad emulation of an A-shaped bulb. So my watt-hour meter is recording about 9.2 watts. The packaging said 9.5, so that's good. And the power factor looks like it's well short of 0.8, so it certainly wouldn't be eligible for ENERGY STAR requirements.